Okay, we'll get started. Today's topic is here, number 6, sixth week, 3D computer graphics and visualization. So far, we have been walked through some building information modeling, parametric modeling, solid modeling, something advanced features in design computing area, okay? Something beyond SketchUp, 3D Max. But in reality, especially for your design studio, design development, design visualization, representation, presentation, we have to deal with geometric modeler as well as some visualization, so-called rendering, okay? But actually today's topic is something in between. We're gonna deal with something advanced features in theory part, and we will get back to some 3D Max and mental way and so on, okay? Most of you already took the course, so you have very well known to the 3D visualization, but as a reminder, we're gonna deal with some series of lab exercises, okay? And also here I list up some rest of semester plans. As you already noticed, we have series of lab exercises, okay, mostly pass-fail, but some qualitative evaluation will be, additional score will be given if your lab exercise is something beyond expectation, okay? And also midterm exam, May 20th, okay? If needed, if changed, it's gonna be announced. Final project is design representation, design presentation using video file, okay? Animation. So your final is supposed to be uploaded on youtube.com, okay? We'll talk about that. That's the third part, okay? We have three major parts. First one is building information modeling using Revit, Vasari, and so on. Second part is design representation using 3D graphics tools and renderers. And the last part is video animation-based design presentation, okay? That's for the final project. And also, I told you before, some other mandatory participation required, okay? Should be showed up in the special guest lecture series. Guest lecture series details will be announced, to be announced later, okay? From the last week, within track 1, theory of building information modeling, and track 2, some series of lab exercises, we have been walked through some object-based modeling using this building, okay? So now you have your building, okay? So today's rest of 2 more lab exercises, no submission for the first one, and second one, only the interoperable work. FBX, using FBX file, your building model, this building model, designed by you, going to be imported into 3D Max and visualized, okay? And you may be noticed that all material, predefined objects, some material maps, Autodesk maps are still alive even in 3D Max if you're using FBX file. So those 2 series of lab exercises are kind of preview. And also we have 2 more weeks next month, okay? Some interoperable work using building information modeling tool and 3D graphics tool and so on, okay? But from this week, 3 more weeks, we're gonna deal with some computer graphics using 3D Max. So this is actually today's lab exercise. As a reminder, most of you are very well known to this, but some of you, if you are not get used to do something by using this kind of 3D geometric modeler and renderer, or even if you have taught this one, but if you forgot everything, today's lab exercise is going to be a good reminder, okay? Okay, let's get into some theoretical part. The first part. Okay, now you know the strengths of BIM, parametric modeling, solid modeling. I mean, something advanced features of computer graphics, computer geometric modeling, information modeling, and so on. Why we need to use such a technology? For explaining this, I showed you last week Seoul City Hall example. Okay. For actual realization of this building design, like this, like those pictures, and those two images are some kind of early phase of design representation images, and something advanced schematic design representation, something detailed in the surface, and the picture after as-built stage. Okay, so the gap between this structure and the early structure, actually at the beginning of the project, it's going to be kind of useless or something intentionally made, this kind of roughly generated design representation. That's fine. But if you use parametric modeling tool or some building information modeling tool, considering constructability, we can make some computational model very close to the real model. Okay, so far, if you draw something by hand, that drawing image is a type of metaphor. Okay, a symbol, not real building or real design or real product. Okay, that's fine in that stage, but if you are in charge of handling some construction issues, manufacturing issues, problems, you have to resolve even in early phase of design. That is why we need such kind of advanced technologies. Okay, that's one thing that I told you last week. And another small example, take a look at this building facade. This is kind of LED exterior lighting, and the surface is kind of wave. This kind of visualization is almost nothing. You can do that in 10, 30 minutes, I believe. But how to make it? How to control it? Okay, that is why we need to this kind of parametrically controllable geometry we need. Okay, this one has CV. CV means control vertex. Okay. Imagine if we are using 3D Max, if you use some editable poly, there are a bunch of points you can control, or FFD, there are control vertices. Okay. By controlling such vertices, you can control the path. Okay, the path of this assembly, not this spline. Okay, controlling this spline is nothing. But by controlling this point and spline, you can control this part, okay, entirely without any joint problem or some mismatched geometry and so on. So this is kind of glowing ribbon-shaped facade using LED and controlled by these parametrics, okay? Okay, next example, this is very well-known DDP, okay? You know this building. Anyone who didn't visit this building yet? Okay, everybody here already stopped by this building? Okay, again, anyone who didn't visit the site, DDP, inside of this building? No one? Except me? Okay. I don't have time to visit this building. But I can explain you how to make it, okay? Take a look at this interior scene, interior of this building. In your perspective, walls, windows always orthogonal. I mean, 90 degrees from ground level. But some walls, some wall objects, even some column objects, windows, curtain wall system, nothing is same. I mean, something diagonal, angled, bended, curved shaped, and so on. Simply because of this building shape is something like this, okay? Very freely designed, freeform, so-called freeform, non-uniform, okay? It's not a box shape. That is why this building interior also not a box shape. Anyway, the building is not a box shape, and the interior also not a box shape. Very unique design. But the problem is design representation. Thanks to your techniques, computer graphics skills, you can design even complex than this building. But the question is how to realize that surface actually, okay? Take a look at this construction picture and take a look at this simple diagram, okay? Several hundreds, thousands of panels used for this building skin, okay, building surface. And each panel has different shape, you know that, different shape, and different style of holes, okay? Something is solid, around 40%, but something has bigger holes, small holes, and in terms of ratio, percentage, you can find out it's very kind of wide open, many holes in blue colored and something solid, white colors, and so on. So how to manufacture this one and how to attach this one, how to make the surface concrete, exposed concrete structure, that's the question. And that was very hard to resolve. That is why this building needed 10 years from planning to as-built construction, okay? 10 years. And take a look at Korea 1, okay? Korea 1. 5천억 won, okay? Korea 1. So where this money come from? Citizens' tax, okay? Taxpayers' money. Because this is Seoul City, public building. Anyway, it's very controversial. Someone very anxious about this building design and its influence and so on, but someone very pleased because of this building design and its influence to Dongdaemun community area. But I'm not talking about that influence or some controversial social, political issues. I'm talking about parametric modeling and some advanced technologies applied for realizing this building, okay? Anyway, thanks to advanced technologies, we can make this building in 10 years, okay? What if we don't have such technologies? Probably still under the construction, I think. The same as Bilbao Guggenheim Museum or Frank Gehry's Disney Concert Hall, they also took several years, long years, okay? So each panel has different shapes, and take a look at the surface. For those panels, surface structure also very differently constructed and carefully managed like this, okay? Take a look at this first stage, BIM modeling, okay? Sorry for those Korean I got from this Seoul City. And some prefabrication for sustaining structure and concrete mold and so on. In this complex structure process, we could make this kind of sustaining structure, and we can install the surface panel. Surface panel also manufactured in very complicated way, okay? Any single panel could be manufactured by very specialized hardware. I didn't put the picture of that hardware. Anyway, the hardware can control the surface angle, bended surface curve, and so on. But precisely controlled by computer, okay? So thanks to this complex process and something trial and failure from this project, we could realize this building anyway. So just, okay, did you have watched this video? Okay, just for fun, let's take a look at this video, okay? This is something about DDP.
This is Scott Thompson from Monday Morning News, reporting live from the Dongdaemun area in Seoul. Korea has become the tourist destination in Asia for sightseeing, shopping, and even plastic surgery, with millions from all across the continent coming each and every year. And when they do, they make sure to stop here at Dongdaemun. What the?
But my point here, again, I'm not talking about this building is kind of UFO shape or something very, it's not that natural. It's not that good for that area, community, Seoul city, whatever. Anyway, so far, the building design and some at least about some number of people visited this building. In terms of that, so far it's successful. Anyway, now we just reviewed something technology aspects of this building in terms of design and construction. So simply we can answer the question why we need such BIM or parametric modeling or some advanced computing powers to realize this kind of UFO shaped buildings. Okay, that's one answer. Let's take a look at some more cases. Before reviewing some cases, let's briefly take a look about some non-uniform building design, okay? Types of non-uniform building. Okay, as you know, we are living in kind of box-shaped building, okay? This building also box-shaped, 90-degree, orthogonal. Nothing is curved, okay? I mean, some architectural element standpoint, ceiling, floor, of course they are parallel and orthogonal, and walls, windows always 90-degree. That is so-called box-shaped building and modernism building. There is no specific inventor of modernism style in architecture, but as you know, Louis Sullivan, Frank Lloyd Wright, hundreds of famous historic architects designed this type of building, okay? Skyscraper of modern city. But actually nowadays we can encounter a bunch of something new style, something different style of building in terms of building shape, building mass, okay? Firstly, diagonal line shaped design, something like this, okay? It's kind of rectangle shape and something linear, not really curved, but something different, right? It's not orthogonal, diagonal, angled, bended, okay? Okay, who designed this? Who's the famous designer, architect in this category, diagonal line shape? Okay, great, great. Daniel Libeskind is very well known to this category, okay? This building, Denver Art Museum. This is Denver Art Museum, designed by Daniel Libeskind, okay? He designed Jewish Museum at Berlin and some ground zero plan for that World Trade Center. Anyway, Daniel Libeskind design has some diagonal lines in both building exterior and building interior, okay? Simply this exterior directly affects inside of the building design, okay? Diagonally angled walls, ceilings, and so on. It's one type of non-uniform design. Second one is segmentation. Actually, we're gonna make this kind of segmentation, segmentized segments for building facade, building interior, using Revit or Vasari later in lab exercise hours. Actually, we're gonna create something like these images. Anyway, who's famous in this kind of design? Who designed this building? Who's the architect? Kub Himmelau. Okay, Kub Himmelau designed this BMW museum at Munich. Okay. Anyway, there are several more architects, designers who love this style of design. Anyway, this is one type of newly developed design and enabled by computing technologies in both design and construction. Okay, parametrically controlled panels. Take a look at this panel, these segments. All panels have flat windows, okay, flat glass. I mean, one single panel is flat, okay, simply because Windows glass is flat, okay. So this is the example. The last one is totally free line curved surface. You know who designed this, okay? This is DDP, Zaha Hadid. Zaha Hadid is very well known to this style of design nowadays, and also a lot more architects, designers, representatively. Frank Gehry's Bilbao Guggenheim Museum, also very world famous building, and Disney Concert Hall, and so on. So this is Rem Koolhaas, totally free line curved surface based design. So those three categories are something non-uniform, something beyond the box shape, okay? So now you can simply categorize the style of so-called freeform, okay? So non-uniform designs can be categorized in this way. So how many buildings you can see in your daily life? Let's take a look at some cases, okay? First case study is tri-bowl. Actually, I put the term bowls, three bowls, but actually, originally it's bowl, okay? B-O-W-L, bowls, okay? Bowls, three bowls. So that's why this building is tri-bowls or tri-bowls. Anyway, tri-bowls, whatever it is, it means three area near Incheon, okay? So take a look at this building, very unique. It's not box-shaped building, totally different, but how to design, how to realize this building, that's the question. Of course, we used I would like to show you some design process, how computing technologies, parametric modeling, design computing things applied for realizing this building. Let's take a look at design process. First important thing is this building design took advantages of something reverse engineering. What is reverse engineering? Reverse direction of engineering? Okay. Usually you create some geometry by using SketchUp, 3D Max, Revit computing technologies, okay, computers. But originally, architect designed that tri-bowl shape by using physical marker models, using styrofoam, isopink, or woodrock, whatever, some hardware, okay? He created that shape first and give them to someone who very skillful, someone who's get used to use computer tools. And he scanned it, okay, laser scan, and generate this digital image at first. That is why they say it's kind of reverse engineering. Anyway, they made markup model first and laser scanned and import that geometry into, this is CATIA. CATIA usually used for manufacturing. For example, Boeing 747 airplane designed by this application, okay, CATIA. Frank Gehry bought CATIA and he regenerated that software named Digital Project. And that is one of the very powerful parametric modeler in architectural design. Disney Concert Hall designed by this application, okay? Anyway, by using Rhino, CATIA, they convert this mock-up image to computational model. And then they made some rapid prototyping using 3D printers, something like this. 3D printer printed out this structure and interior floors and connections, bridges, corridors, walls, and so on, just for reviewing building interior and some actual prototypes by using that model. And they get back to this model and try to make some optimized model, geometry optimization, simply because sometimes the edges or some banded points sometimes really hard to make, or sometimes it's going to be something dangerous in terms of safety, in terms of structural analysis, and so on. They want to make some optimized model, something constructible design, okay? So they try to cut the pieces, and they try to make some manufacturable, constructible structure for this entire building structure, okay? And then they use parametric modeling technologies so that they can make some quantity takeoff. How many panels, how many structural objects required for this building, how to compute them. That's why they use that kind of technologies. Let's take a look at these pictures. Under the construction, this is the construction site, structure, and the surface concrete structure here, and the panel installation. In this building, 2,600 individual panels used. Comparatively, compared to DDP, not that many panels, but anyway, 2,600 panels individually manufactured. Okay, for example, this panel has its ID, 2A-2B-101, something like that. This one, 2A-2B-102, something like that, okay? Total 2,600 individual panel has different ID, different location, and according to that IDs numbers, this one could be installed, okay? Actually, this is not glass panel. This is anodized aluminum panel, okay? That's why this one can be bended, curved, okay? If those panels are glass panel, cotton wool system, any single panel is going to be flat. But anyway, this is curved surface. No windows, this building, okay? At least you see here, but some windows, probably openings, of course. But anyway, mostly covered by this anodizing panel. Take a look at this panelization. This is early phase of panelization. In early phase of paneling, this software automatically generates this kind of panel subdivisions. But this one also should be optimized according to interior design, structural design, and so on. So geometric shape design first, and floor modeling. Actually, this is floor, okay? Take a look at this floor. It's very freeform shape, curved, and not box shape. Anyway, floor modeling should be stacked inside of this three bowl shape, and surface pattern design should be updated. Paneling, structural object hierarchy, relation. If some interior architect changed the space according to some owners or some users' requirement, in that case, exterior paneling or structure could be affected, and this one should be changed, and vice versa. Because of some structural analysis issue or some safety issue, structure can be changed, updated, and then interior objects should be updated as well as that changes, okay? How to update them all in real time? That's why we need to use this kind of highly advanced and very precisely controlled geometry. by using these numbers, okay? Take a look at this hierarchy. In Revit, we experienced this kind of structure, okay? Some plan views and some 3D views. We use some views, but actually objects also have different structure and relation. And this structure can be reusable and very efficient and productive for next project. Even if the geometry is totally changed, the system approach mechanism is almost same if it's very well developed, okay? So anyway, this building is kind of award-winning building, very good design building. You know that. Anyone who visited this building? Okay. Take a look at this series of pictures. Actually, I would like to put more emphasis on building interior, inside the spaces. Take a look this building inside interior space. Have you seen this type of diagonally angled walls? This is wall, anyway. Also another wall and structure, truss for structural part, and the corridor floor. Nothing is flat except floor. Nothing is orthogonal except floor. Take a look this interior. So how to design, how to make this design more unique and something good space for people. That's another issue. This is obviously not a box shape, interior. So how to resolve such problem, given problem? How to make this building interior, inside, kind of enhanced? That's another question in terms of interior architect. Okay, next example is Salvador Dali Museum, designed by HOK. HOK is one of the world leading architect company, and in terms of BIM consultation and BIM management and construction management, back group, okay? So take a look at this example. I roughly showed you this one last week, but actually this building is kind of good example in terms of building information modeling based approach. This is design process. Take a look at this building shape. Actually very typical and modern style box shape building. But take a look at this building core structure and exterior structure. Very weird, strange shape. But anyway, this one is kind of unique part of this, on top of this box shape building. Probably in your survey, in your design research for your design studio, you might be noticed that there are several similar style of building renewal or reconstruction. By using conventional old type building, mostly in box shape, put something unique by using this kind of non-uniform design, freeform design for building facade, building exterior, or some additional wall system, or this kind of core system, and so on. This one actually designed by Revit and some similar parametric design tools. This one, visualization, looking kind of simple, but also visualized by such tools. And take a look at this section view. Thanks to this structure, building interior also dramatically changed. And structural analysis could be done in design phase too, okay? Thanks to this type of modeling. This is early phase of design visualization. But take a look at this visualization and take a look at this picture, okay? Different? I think almost same, totally same. But the one that I showed you before using Seoul City Hall, very different, okay? At that time, early phase of visualization is kind of symbol, kind of sketch, separately generated. But this one modeled by BIM application. So BIM authoring tool can visualize something like this, even in early phase of design. But this visualization is almost same, okay, in terms of its structure and so on, simply because it's modeled by BIM and constructed by using that BIM model originally, okay? So this is early phase of visualization, and this is the construction picture. And after as built, this is the picture of the building core, lobby space. Very unique, even if it's box-shaped building, thanks to that structure. This is rhomboid panel, triangular shaped curtain panel system, okay? Segmentation, segmentized. Each segment has triangular shape. Anyway, everything is flat surface. But anyway, the assembly is non-uniform shape. And also another unique design feature, this spiral shape of stairwell. Take a look at these snapshots. This is a Revit screenshot, removal of ceiling, roof structure, as well as this unique feature of the addition. But after this addition, building design could be dramatically changed and make some unique point of this building design, okay? This type of design realization could be maximized in terms of its efficiency and some economic aspects by using such advanced technologies, okay? BIM, IPD, we didn't yet take a look some IPD issues. It's integrated project delivery. But anyway, BIM-based parametric modeling and some information-based approach, even from early phase of design, can realize this building efficiently, okay? Okay, obviously, building information modeling, parametric modeling, even other advanced tools, advanced design computing technologies are the promising way to go, okay? We know that. But actually, for your design visualization, design representation, specifically for your design studio work, okay? You are in several design studio work. Still, we need to use some visualization tools, 3D geometry tools, okay? Simply because they are very easy to use for making your design visualization, design representation, okay? That is why this final project is video-based design presentation by using YouTube and some animation making techniques. Anyway, we now we're gonna switch kind of study mode and lab exercise mode from BIM to conventional 3D computer graphics, okay? As a reminder and review, and someone is very new to this one as well, I think. Anyway, 3D computer graphics and visualization of your design. Let's take a look at some fundamental issues and some basics again. Computer graphics and visualization, where you are involved in terms of this building life cycle, okay? In terms of building life cycle, building can be planned by usually numbers. Sometimes that numbers are money or some space requirement, size of the building, and so on, okay? So specification level, and we need to draw something. Draw some floor plans, elevations, building mass, sketch 3D view, and so on. In that point, even from early phase of design, planning phase, we use computers, okay? Some spreadsheet, Excel file, usually Excel file, or some database, or some documents, and so on. So we need to visualize that numbers by using some drawings, okay? Sometimes very symbolic design drawings, such as floor plan, elevation section, some 3D standardized visualizations, but sometimes very detailed 3D renderings and so on. And then we need to review, analyze, and simulate design to evaluate that design is enough or good. Iteration, okay? Design, review, and update again, and so on. And then we need to foresee how to make this building realized. So that's why we need to use some rapid prototyping, digital fabrication, planning for construction, construction management, and so on. So quantity takeoff, cost estimate, we can do that in this level of detail, okay? Now we have very detailed model so that we can make some prototypes and some fabricated models, and we can estimate quantities as well as construction money and so on. So we have details. We have mechanical system, electrical system, and so on. Electric system, plumbings, and so on. So we can make some clash detection and detailed construction process for this simulation. And we can make it as built in operation, okay? Sometimes this building life cycle, mostly operation has more than 90% of building life cycle. In operation, we can update design, okay? I mean, some reconstruct, as this building reconstructed 2 years ago, 3 years ago, okay? So at that time, we need to get some specification. We need to visualize something and rearrange spaces by using drawings and review again and again, and partially reconstructed in operation stage. So entire 100, 200, sometimes just 50 years, anyway, very long years. This is building life cycle, very simplified building life cycle. When we need to visualize design, when we need to capture as is status. So especially drawing stage, we need visualizations. In your design studio, you are in this stage, okay? Design stage, especially early schematic design stage, not detailed design or documentation stage. Actually, very early phase of design. That's what you are dealing with in your design studio, okay? Very tiny part of building life cycle. In terms of percentage, probably 1 or 2%, okay? Anyway, in that area, we need visualization, importantly. But in design review, simulation, foreseeing the construction, for the simulation, crash detection, even cost estimate and quantity takeoff, we need different type of visualizations and so on. Entire process, we need make some visualizations. What if we need some visualizations in operation for facility management? Easiest way is to take pictures, okay? Because it's already as built. But we can reuse some visualizations generated in design phase, okay? And so on, vice versa. Computer-based visualization is kind of never-ending, okay? Always we need something different type of visualizations. Even if you are focusing on this area, early phase of design. So what is design visualization? What is computer graphics? We have walked through rendering, okay? Now it's time to get back to some rendering using 3D geometric tools. But I told you before, design visualization is so-called rendering, computer-based rendering. But manual rendering, you can render by hand, okay? If you draw some sketch, that is another type of rendering, okay? Anyway, everything here is rendering, but different types. Line stroke-based rendering, photorealistic rendering, okay? Some intermediate rendering, color fill, shaded rendering, and so on. This is all about lights, okay? That's what I'm talking about. In terms of light and object and camera, we have three major features, and what you have to know is those three important parts, one by one, okay? Under lighting, there are some direct illumination, representatively sunlight, default light. But we use mental ray sun, V-ray sun, and so on, because it's much better direct illumination. Also indirect illumination, some photometric lighting system, artificial lighting, and so on. Sometimes we can control environment so that we can see by using as a default light. How about camera? It's easy. Source, target, field of view, some camera techniques we need to control for your visualization. But others, objects. Under objects, there are some important keywords: diffuse, reflection, refraction, caustics, and so on. Under diffuse intensity, the length, the strength of the light, texture map, shadow casting, ambient occlusion, and so on. All those terms can be found in renderer, okay? Mental ray, V-ray. Those structure can be placed under reflection too, all same, okay? So this is review. And it's time to see again 3D Max, okay? Autodesk 3D Max, by using 3D Max, or even by other general 3D tools such as Rhino, SketchUp, even by AutoCAD, what to do? Here I list up very important features, what to do by using such geometry and visualization tool. Firstly, the most important thing is modeling, of course. The term modeling here is geometric modeling, okay, not information modeling. One subset of information modeling, building information modeling, is kind of bigger part of geometry modeling because geometry is one part of building information. Anyway, the term modeling here is geometric modeling to create objects. Next one is, of course, visualization. Without objects, there is nothing to visualize. That is why modeling is the first one. And second one, visualize scene. That's what we are dealing with in this lab exercise. Rendering, okay? The last one, animation, but this one is kind of extended version of rendering, simply because animation is series of still images, okay? Flipbook animation, and so on. Under the modeling, simply say it's very hard to do, and it's usually tedious and time-consuming, and highly skillful techniques required. So you have to learn by trial and failure. You have to learn by Google, not from me, okay? That's very important. Of course, we're going to deal with amount of things in lab exercises, but I'm not teaching you which button you have to click for specific thing you want to do. You can search it. You can retrieve. Someone can retrieve that information in 30 seconds. Someone cannot find out until end of the semester. That's big difference between you guys, okay, as always. And rendering, many things to take care of, but it's not that hard, easy, comparatively. Under modeling, three things I list up. Create 2D geometry or 3D geometry. Anyway, you have to create 2D first, and then extrude it, revolve it, and then final object is 3D. There are several ways of creating 3D. Next one is simply import geometry from Trimble, 3D warehouse, or your friend's SketchUp file, whatever, okay? Reuse geometry. The last one is the most time-consuming thing, manage objects, modification, iteration, never-ending modification, okay? Under rendering, assign material, add light, set up camera, and control render options, material options, and render it. That's it, okay? Very intuitive, but you need some technique. Mostly we are dealing with those parts. So This one single slide is looking very simple, but this one is almost everything about 3D Max or similar tools, okay? I know this one, number 3, this one probably takes several days. This one takes several days for one design visualization, but anyway, we need to use this mechanism. You have to understand, comprehend the mechanism and process so that you can apply this mechanism to different application. Any single application, Rhino, 3D Max, SketchUp, behind the technologies are almost same. But what's different? User interface is different, okay? So you don't have time to get used to such different user interfaces. You have to spend more time on understanding these issues and learn user interface by using YouTube, Google, quickly. In that way, you can learn any 3D software, okay? Okay. 3D Max, very different interface, icons, menu bars, too many buttons, too many options, time slider, and sometimes unidentified buttons, icons, even if this is 2009 version, okay? But anyway, this one has Cartesian coordinate system, workspace, steering wheel, same, two recently developed tools. And just for your technique, we have to use hotkeys. And this is 3D Max design, actually 2014 version. But today we're going to use 2015 version. And unfortunately, next month, 2016 version will be released from Autodesk. Okay? Usually in May, Autodesk release their next year. So 2016 version gonna be released. We are not sure how it looks like. Its interface probably dramatically updated, changed, but behind the technology mechanism all same. What we need to do is get used to that user interface, okay? Anyway, this is 3D Max 2015 and the hotkeys. The reason for showing you this one again is, as a reminder, take a look at W means move tool in 3D Max for easy to use 3D Max and so on. And utility, Shift Q means rendering and so on. You need to remind 3D Max for today's lab exercise. Okay, for interior architects, or even just general designers, architects, here I put some use scenario in different way, okay? First thing you have to do is defining UOD. You know what's UOD? Universe of this course, okay? If your universe has some Mickey Mouse, you have to model Mickey Mouse, okay? But usually you don't have such things. In your universe, there is flat floor and 4 walls and 1 ceiling and 2 lighting and a desk. Very simple building interior, okay? In that case, you have to write down which objects you need, okay? Okay, you are designing some interior objects, furniture. In that case, architectural elements could be imported. You can model it quickly by using Revit and import into 3D Max and design something in 3D Max, or import another object from different source, for example, SketchUp, and easily, quickly make some photorealistic rendering. In terms of that first definition, you have to write down the objects first, okay? What's in your mind? You have to know first. But sometimes you got some failure in 3D computer graphics simply because you didn't define your word, your objects. Just to do it. Thanks to Nike, you just do something by using 3D Max, eventually failure, okay? Because you don't know what to do. That's why you got that failure. You have to define your world first. Of course, it doesn't mean that you have to define perfect thing first. You can update that universe while you are working on. Next thing is modeling. Within modeling, firstly, modeling universe, modeling environment, modeling this room first, and then create your design elements, okay? On the universe modeling, environment modeling, sometimes planes. Planes is not 3D. In Revit, flow object has thickness, simply because that is real, okay? Any single slab has thickness. Nothing is surface. But in 3D Max, plane is okay. No one sees floor thickness, okay? In that case, just for visualization purpose. And you need to define walls. Of course, you don't need to put thickness, but it's okay. Some surface-based walls. Anyway, sky, outside view, it's okay just to put a picture just behind that window, kind of fake environment. But that's fine because only we see that windows only. And kind of never-ending modification. 2D modeling, 2D sketch, 3D modeling, import geometry, and iterations of modification, and rendering, okay? In rendering, material mapping, lights, camera, rendering scenes, options, control, back and forth, okay? Render it, modify it, render it, and retouch for final product. Sometimes by using Photoshop, power user of Photoshop always the winner because dramatically enhanced outputs can be generated by power users of 2D image generation. Because anyway, final output is 2D image usually. But something different story in animation making. Animation, it's not simple 2D. But even in that animation, Photoshop is very important, okay? 30 images for 1 second, 300 images for 10 seconds. So edit 300 images in Photoshop one by one, manually, and make it 10 seconds animation, much better, okay? We will deal with that part too, from something from last semester, last class. Anyway, this diagram is another simplified one page, but this one tells you almost everything about use scenario of 3D Max or even any other 3D tools, Rhino, SketchUp, AutoCAD, whatever, okay? Very different from Revit, okay? Revit is very similar to real-world object and real-world scenario, but this is kind of fake, okay? Surface-based 3D, virtual, pseudo, fake environment. That's why we can make this one in this way. But my point here is you have to know how to take advantages of, how to take maximum advantages of such surface-based visualization tools and geometric tools, okay? Here I put, again, in text, use scenario. Just some additional tips, okay? Before modeling and rendering, defining UOD first. Roughly design your universe, even by hand drawing sketch. And model your objects, okay? Even if it's very tedious, time-consuming, anyway, handle them. Reuse geometry from your model, others' open model, and so on. For rendering, to make some realistic things, we have to understand some theories behind the techniques. Originally, scientist Newton developed and invented theory, lights, okay? All about lights. We use very good renderer, mental ray, or V-ray. They are all ray trace based renderer. Ray means sun ray or lighting ray, we need to track each ray one by one, even if it's millions of rays. And then we can track shadow, reflection, partial reflection, and so on. Additional indirect lighting, and so on. That's why we can make photorealistic renderings. But you don't need to make always photorealistic rendering, but anyway, sometimes it's important. So some retouch applications such as Photoshop also very important. That's what I described here, some use scenario. Let's take a look at this one again. Very well-known renderer, mental ray. Take a look at this image. Thanks to mental ray lighting system, and another thing, Autodesk material, predefined materials. What you need to do is simply assign different material: chrome, glass, plastic, wood, high glossy wood, and matte wood, something like that. And then you can generate totally different material, okay? All predefined. Just assign it. And some few options, simplified options available, easy to control. So thanks to Autodesk material, we can reuse Autodesk material, and very easy and flexible. Okay, you modeled Revit model of this building last week, okay? You have this building model. In Revit, you mostly modeled walls, windows, floor, doors, and so on by using some default. But Revit is also Autodesk tool, and default material is Autodesk material. In other words, your furniture, your door, your window, all have default Autodesk material. So if you export Revit model by using FBX, which support Autodesk material, you can import that into 3D Max, and you can render it without any additional texture map. What you need to do is controlling light system. That's it. And then you can visualize this building model in 3D Max much faster and better, okay, by using mental ray. Thanks to Autodesk material. They are kind of interoperable, okay? Anyway, thanks to advanced renderer embedded in 3D Max, V-Ray is plugin, not default embedded software. Anyway, thanks to mental ray, we can make that kind of image quickly, easily. Today's lab, one of the lab exercise is to visualize your Revit model of this building in mental ray, 3D Max, okay? I'll let you know in the lab exercise number 10. Okay, lab exercise, okay?